In this video, we're going to be solving the October-November 2023 question paper 61 for the CIE A Level Maths 9709 exam board. Subscribe and let's get into it. Number 1. A random variable x has the distribution normal with mean 410 and variance 400. Find the probability that the mean of a random sample of 36 values of x is less than 405. Okay, so let x bar be the RV sample mean of 36 values of x. So this means that x bar follows a normal distribution with mean 410 and variance 400 over n, which is 36. And we want to find the probability that x bar is less than 405. So let's standardize that z is less than 405 minus 410, and this is all over the square root of 400 over 36. Let's plug this into a calculator. That's 405 minus 410 over the square root of 400 over 36, and that gives us negative 1.5. Negative 1.5. So this is 1 minus phi of 1.5. Let's read the value of phi of 1.5 from the normal distribution tables. That's 0.9332. And this simplifies to give 0.0668, and that would be our final answer. Number 2. In a survey of 300 randomly chosen adults in Rickton, 134 say that they exercise regularly. This information was used to calculate an alpha % confidence interval for the proportion of adults in Rickton who exercise regularly. The upper bound of the confidence interval was found to be 0.487, correct to 3 significant figures. Find the value of alpha correct to the nearest integer. So the formula to get the upper bound of a confidence interval for a proportion is the proportion of the sample plus z times ps times qs over n. And this should give you the upper bound. In this case, our upper bound is 0.487. Now our proportion PS is 134 out of 300. So that's 134 over 300 plus Z. And this is the square root of 134 over 300. And QS is 1 minus 134 over 300. That is 83 over 150. 83 over 150. And this is all over n, and our n is 300. This is equal to 0.487. Okay, so now let's make z the subject of the formula. So z would be equal to 0.487 minus 134 over 300, and this is all being divided by the square root of 134 over 300 times 83 over 150 divided by 300. Let's punch this into a calculator. So that's 0.487 minus 134 over 300, and this is divided by the square root of 134 over 300 times 83 over 150 over 300, and this gives us 1.405, correct to 3 decimal places. Now when we're talking of a confidence interval, we want the region that's in the middle. So we're looking for alpha %. So alpha would be this region here in the middle, alpha %, and we have the z value for the upper bound. So that's 1.405, which means the lower bound would be negative 1.405. So if we want the area of alpha percent, we can simply say 2 times phi of 1.405 minus 1. So let's read off phi of 1.405 from the tables. That's 0.9199 minus 1. And if we simplify this, 2 times 0.9199 minus 1, that gives us 0.8398. 0.8398. Now let's multiply it by 100 to give it as a percentage. So times 100, we get 83.98%. The question states that we should give our answer as, or correct to the nearest integer. So that means our final answer would be, therefore, alpha is equal to 84, since they wanted correct to the nearest integer. Number 3, a website owner finds that on average his website receives 0.3 hits per minute. He believes that the number of hits per minute follows a Poisson distribution. Part A, assume that the owner is correct. Part 1, find the probability that there will be at least 4 hits during a 10-minute period. So notice the interval change here. We're given the average rate in terms of per minute, but then the question is asking in terms of a 10-minute period. So it means that if we were to say that let x be the RV hits per 10-minute period, 10-minute period, it means that x follows a Poisson distribution with 0.3 times 10, since we're now dealing with a 10-minute period, which should give us 3. And we want the probability that x is at least 4. So that's greater than or equal to 4. And we can write this as 1 minus the probability that x is less than 4. So that would be 1 minus e to the negative lambda, which is 3. And then we want x equals 3, x equals 2, x equals 1, and x equals 0. So we start with when x is equal to 3. So that's 3 to the power 3 over 3 factorial plus lambda 3 to the power 2 over 2 factorial, and that's plus, this would be 3 and then plus 1. And if we punch this into a calculator, that's 1 minus e to the negative 3, open bracket, 3 to the power 3 over 3 factorial plus 3 to the power 2 over 2 factorial plus 3 plus 1. And this gives us 0.353, and that would be our final answer. Part 2. Use a suitable approximating distribution to find the probability that there will be fewer than 40 hits during a 3-hour period. So now it's, instead of being per 10 minutes, it's now per 3-hour period. So we're told that it's 0.3 hits per minute, and 3 hours is equivalent to 180 minutes. So it means our lambda now is 0.3 times 180, and that's 0.3 times 180, that gives us 54. So if we were to say let y be the RV hits per 3 hours, we're saying that y follows a Poisson distribution with lambda 54, and since lambda is equal to 54, which is greater than 15, we can use the normal approximation to the Poisson distribution. Normal approximation. And so that means y follows a normal distribution with mean lambda, which is 54, and variance lambda. and would like to find the probability that there are fewer than 40 hits. So y is less than 40. And since we're moving from a discrete distribution to a continuous distribution, we have to apply continuity correction. Remember that 40 represents any number from 39.5 to 40.5 in a continuous distribution. And since we want less than 40, it means we don't want to include 40, so we're saying less than 39.5. So this is the probability that y is less than 39.5. And if we standardize, that's the probability that z is less than 39.5 minus 54 over root 54, and that gives us the probability that z is less than, let's punch this into a calculator, 39.5 minus 54 over root 54, and that simplifies to give negative 1.973, which can be written as 1 minus phi of 1.973. And if we read off the value of phi of 1.973 from our tables, we get 0.9758, which gives us, this is 1 minus 0.9758, and that gives us 0.0242, and therefore our final answer is 0.0242. A friend agrees that the website receives on average 0.3 hits per minute. However, she notices that the number of hits during the daytime, 9 a.m. to 9 p.m., is usually about twice the number of hits during the night time, 9 p.m. to 9 a.m. Part B, Part 1. Explain why this fact contradicts the owner's belief that the number of hits per minute follows a Poisson distribution. So for a Poisson distribution to be suitable, there are 4 conditions that have to be satisfied. Events must occur singly at a constant average rate, and they must occur randomly as well as independently. So in this case, if the number of hits per minute during the daytime is twice the number of hits during the nighttime, it means that the constant average rate or the mean is not constant. As a result, the Poisson distribution is not suitable. So we can say that the mean is not constant. Part 2. Specify separate Poisson distributions that might be suitable models for the number of hits during the daytime and during the night time. Okay, so we're going to say let P equals hits during night time. During night time. So we're saying that on average there are 0.3 hits per minute, right? So we've got 0.3 hits per minute. 0.3 hits per minute on average, and then we're told that hits during the daytime are twice the hits during the nighttime. So since we have defined the hits during the nighttime as P, we're saying that the daytime hits would be 2P, and the average of P plus 2P would be equal to 0.3. So let's multiply both sides by 2 to get rid of the denominator. That's P plus 2P is equal to 0.6. This is 3P is equal to 0.6. So P is equal to 0.6 over 3P is equal to, let's punch that into the calculator, 0.6 over 3, that's 0.2. So if we say let N be RV, hits per minute during night time, and then let D be RV, hits per minute during daytime, during day. We can therefore conclude that n follows a Poisson distribution with lambda 0.2, and then d follows a Poisson distribution with lambda. We say that during the daytime the hits are 2p, so 2 times 0.2, which is 0.4, and this would be our final answer. Number 4, the masses in kilograms of chemicals A and B produced per day by a factory are modeled by the independent random variables x and y respectively, where x follows a normal distribution with mean 10.3 and variance 5.76, and y follows a normal distribution with mean 11.4 and variance 9.61. The income generated by the chemicals is $2.50 per kilogram for A and $3.25 per kilogram for B. Part A. Find the mean and variance of the daily income generated by chemical A. So A has the normal distribution with mean 10.3 and variance 5.76, and we're told that the income it generates is $2.5 per kilogram. So we're saying that the income for A is equal to 2.50 times x. And so we need to find the expectation, which is the mean. Expectation of A will be 2.50 times 10.3. Let's punch that into the calculator. 2.5 times 10.3, that gives us 25.75. So therefore the expectation of A is equal to $25.75, and then the variance of A would be equal to 2.50 squared times the variance, which is 5.76. So the variance for A would be equal to, if we punch that into the calculator, 2.5 squared times 5.76, that gives us 36. Let's move on to part B. Find the probability that on a randomly chosen day, the income generated by chemical A is greater than the income generated by chemical B. Okay, so we want to find the probability that A is greater than B. So if we move B to the left hand side, we can write this as the probability that A minus B is greater than 0. We've already defined A as 2.5x, 2.50x, and we're told that B is 3.25y. So now we're going to let's call A minus B D, saying D is equal to A minus B. So let's find the expectation of D. Expectation of D would be 2.50x minus B, which is over here, 3.25y, 3.25y. So the expectation of D is equal to, we already calculated 2.50 times x in part 1, which gave us 25.75. 25.75 minus 3.25, and the mean of y, which is 11.4. So that's 11.4. The expectation of D is, let's punch that into the calculator, 25.75 minus 3.25 times 11.4, and that gives us negative 11.3. Negative 11.3. Now let's get the variance of D. That's equal to 2.50 squared times the variance of x plus 3.25 squared times the variance of y. Remember that variance is always positive. So var of D is equal to 2.50 squared times var of x. We calculated that in part A and it gave us 36. So that's 36 plus 3.25 squared times the variance of y, which is 9.61. So 9.61, let's punch this into our calculator. That is 36 plus 3.25 squared times 9.61, and that gives us 137.50. I'll give this correct to 4 decimal places. And this means that D follows a normal distribution with mean negative 11.3 and variance 137.5056. And we said we wanted the probability that A minus B is greater than 0, and we defined A minus B as D. So this means that what we're looking for is the probability that D is greater than 0. So this becomes, if we standardize, it becomes 0 minus 11.3, so 0 plus 11.3, all over the square root of 137.5056. Let's punch this into the calculator. That's 11.3 over the square root of 137.5056, and that gives us 0.964. So this is 1 minus 5 of 0.964. Let's read off the value from our normal distribution tables, and that is 0.8325. And if we punch this into the calculator, 1 minus 0.8325, we get 0.168, correct to 3 significant figures, and this is our final answer. Number 5. In the past, the number of inquiries per minute at a customer service desk has been modeled by a random variable with distribution Poisson and lambda 0.31. Following a change in the position of the disk, it is expected that the mean number of inquiries per minute will increase. In order to test whether this is the case, the total number of inquiries during a randomly chosen 5-minute period is noted. You should assume that a Poisson model is still appropriate. Given that the total number of inquiries is 5, carry out the test at the 2.5 significance level. Okay, so we are given that a random variable has the distribution Poisson with lambda 0.31. So let's define x as the RV inquiries, or rather the number of inquiries per 5-minute period, So this will mean that x follows a Poisson distribution with lambda, and then our now hypothesis is that lambda is equal to, if we multiply this, since this is given per minute, we can multiply that by 5, 0.31 by 5, and we get 1.55. So that means lambda is equal to 1.55 for our null hypothesis. And then for alternative hypothesis, lambda is, they expect this value to increase, so lambda is greater than 1.55. So assuming H0 is true, we can say that x follows a Poisson distribution with lambda as 1.55. And now we're testing at the 2.5 significance level, 2.5 sig level, and this is an upper tail test. So upper tail test. So let's create our rejection rule. We can say reject H0 if the probability that x is greater than, remember that this will take the sign of your h1, greater than or equal to C if this is less than our significance level. So that's 0.025. And now we've been given that the total number of inquiries is 5. Carry out the test at the 2.5 significance level. So our test statistic 5. So let's evaluate the probability that x is greater than or equal to 5. And we're using the distribution x follows a Poisson distribution with lambda 1.55. So this is 1 minus the probability that x is less than 5. And so that's 1 minus e to the negative lambda, which is 1.55. And then we'll do lambda to the power of 4 over 4 factorial plus lambda to the power 3 over 3 factorial plus lambda to the power 2 over 2 factorial plus lambda plus 1. Let's punch this into the calculator. 1 minus e to the negative 1.55 open bracket 1.55 to the power 4 over 4 factorial plus 1.55 to the power 3 over 3 factorial plus 1.55 squared over 2 factorial plus 1.55 plus 1, and this gives us 0.0210. And now let's go back to our rejection rule and substitute this with our value. So 0.0210, is that less than or greater than 0.025? We can see that this is less than 0.025. So we can therefore conclude that reject H0 in favor of H1. And now we have to conclude in context and say that there is evidence at the 2.5% significance level that the number of inquiries has increased. The number of inquiries, that's the correct spelling. Inquiries, yes, has increased. And this would be our final answer. Number 6. A continuous random variable x takes values from 0 to 6 only and has a probability distribution that is symmetrical. Two values a and b of x are such that the probability that x is between a and b is equal to p, and the probability that x is between b and 3 is equal to 13 over 10 p, where p is a positive constant. Part A, show that p is less than or equal to 5 over 23. Okay, so let's sketch a diagram of what our PDF would look like. So this is the x-axis, that's the y, and I'm just going to draw something symmetrical. Since the keyword there they gave us in the stem is symmetrical, they didn't tell us the shape of the PDF, they didn't tell us what type of function it is, and they told us it runs from 0 to 6. And since it's symmetrical, it means that the middle point is equal to 3. And now let's evaluate some of the information we've been given. I'll use a different color for this. So we were given that the probability that x is between a and b is equal to p. Okay, so I'll put a somewhere here. This is a, and then we know for sure that b must be less than 3, since they've given us that the probability that x is between b and 3 is equal to 13 over 10p. So b will possibly be somewhere here. Okay, and so that means this region that I've shaded in red, that's between a and b, that's equal to p. And then we have the region that's between B and 3. Let me use a different color for that. This region over here, this region in gray, that is equal to 13 over 10 P, where P is a positive constant, and we're required to show that P is less than or equal to 5 over 23. Since our PDF is symmetrical, it means that the region probability that x is less than 3 is equal to 0.5. Since it's symmetrical, the area to the left of 3 is equal to 0.5. And from here, we were just estimating where to put A and B. We don't know exactly where they lie. So this must mean that the probability that x is between A and 3 is less than or equal to 0.5. Since they haven't told us where A lies exactly, for all we know, A could be at 0, and that would mean that that region is exactly 0.5. So we can assume that it's less than or equal to 0.5. And for that reason, we can therefore say that the probability of x being between b and 3 is 13 over 10p plus the probability of being between a and b is equal to p, and this is less than or equal to 0.5. So the probability of x being between a and 3 is a combination of these two probabilities, and that's what we've done. We've simply added them together here, and if we add them, that's 23 over 10 p is less than or equal to 0.5. So p is less than or equal to 0.5 times 10 over 23. Punch that into your calculator. 0.5 times 10 over 23, that gives you 5 over 23. So p is less than or equal to 5 over 23, and that's the final answer. Part B. Find the probability that x is between b and 6 minus a in terms of p. So let's draw a diagram again. So this would be our x-axis, and that's our y. We've got our PDF, and it runs from 0 to 6 with the median being 3, and we know that we have b being somewhere here and a being somewhere there. So 6 minus a is symmetrical to this region over here, and it would be somewhere here. This would be 6 minus a. That would be that region. What we want, let me just remove the area that I shaded. And so what we want is, let's do it in red, the probability that x is between b and 6 minus a. So this region over here, the region I've shaded in red. So what we can do is to simply say 1. We know that the total area under the curve is 1. So 1 minus this region from 0 to b minus this region from 6 minus a to 6. And to get that, we can do, let's start with this region from 0 to b. We can say that this region is 0.5 minus, we know the area from b to 3 is 13 over 10 p, and we know that the region from a to b is p. So that means 0.5, which is halfway, minus this region minus that region should give us this small part remaining over here, and that small part is the same as this region over here. And now we also want to subtract this region from b, right? And what we can do is to say 0.5 minus this region over here from 3 to b. Let me just erase that so that it doesn't look as messy. So now to get this region from 0 to b, this region, Yeah, we can simply say that the area from 0 to 3 is 0.5 minus the area from B to 3, which we know is 13 over 10 P. And now we can just simplify this whole expression. That's 1 minus 0.5 plus 13 over 10 P plus P minus 0.5 plus 13 over 10 P. Simplify like terms, so you end up with 1 minus 1 plus, that's 23 over 10 P plus 13 over 10 P, and so this results in, that's 36 over 10 P, 36 over 10 P, which gives us 18 over 5 P, or 3.6 P. So we can say that therefore our final answer is 3.6 P. It is now given that the probability density function of x is f, where f of x is equal to 1 over 36 times 6x minus x squared, for x is between 0 and 6 and 0 otherwise. Part C, given that b is equal to 2 and p is equal to 5 over 27, find the value of a. Okay, so if we go back to the stem of the question, we were told that the probability that x is between a and b is equal to p, and so now we can use that to evaluate a. Let me just change the color back to blue. The probability that x is between a and b is equal to p. So we know that b is 2 and p is 5 over 27, and to get the probability that x is between a and 2, we can integrate with a as the lower limit and 2 as the upper limit. Let's put 1 over 36 outside, and this is 6x minus x squared with respect to x is equal to 5 over 27. So if we integrate, that's 6x squared over 2, which gives us 3x squared, minus x cubed over 3. There should be a 1 over 36 here. And our limits are from a to 2. This is equal to 5 over 27. Let's substitute in our limits. 1 over 36. The upper limit, which is 2 squared minus 2 cubed over 3, minus the lower limit 3a squared minus a cubed over 3, and this is all equal to 5 over 27. So this becomes 1 over 36 times, let's simplify for the upper limit, that's 3 times 2 squared minus 2 cubed over 3, and that gives us 28 over 3. So this is 28 over 3 minus, let's expand this bracket, 3a squared plus a cubed over 3, and this is equal to 5 over 27, and then multiply both sides by 36 to get rid of the denominators. So this becomes 28 over 3 minus 3a squared plus a cubed over 3 is equal to, that's 5 over 27 by 36, that gives us 20 over 3. Let's multiply it through by 3, that's 28 minus 3a squared times 3 plus a cubed is equal to 20, so this is 28 minus 9a squared plus a cubed is equal to 20. And let's put all the terms on one side and arrange this in descending powers of a. So that's plus 28 minus 20 is equal to 0. So a cubed minus 9a squared plus 8 is equal to 0. Okay, so now we have a cubic function, and we have to solve the cubic function. So to be able to solve a cubic function, we first have to reduce it to its quadratic factor and its linear factor. In this case, we don't have any roots of the quadratic, so what we'll do is we'll use trial and error to find any roots. So if you substitute a 0, you'd get 8, so that's not gonna work. Let's try a is equal to 1. So that would be 1 cubed minus 9 times 1 squared plus 8. So 1 minus 9 plus 8, which is negative 8 plus 8. This does give us 0. So that must mean a minus 1 is a root of our cubic function. Do we have space there? No, we don't have space. As a result, we can now divide our polynomial using long division to get our quadratic root. So that's plus 8. So this is a cubed divided by a, which gives us a squared. So that's a squared times a, which is a cubed. A squared times negative 1, negative a squared. And if we divide, that's a cubed minus a cubed, which is 0, negative 9a squared plus a squared. That's negative 8a squared. Bring down the 8, that's plus 8. So negative 8a squared divided by a, that is negative 8a. And then if we multiply negative 8a by a, you get negative 8a squared. Negative 8a by negative 1, you get positive 8a. And so that becomes negative 8a squared plus 8a squared, which cancels. And then we've got negative 8a, and then we bring down that 8, that's plus 8. So that's negative 8a divided by a, which gives us negative 8. And if we multiply through, that's negative 8 times a, negative 8a. Negative 8 times negative 1, that's positive 8. And this all cancels out to give 0, which means that our quadratic factor is a squared minus 8a minus 8, and our linear factor is a minus 1. And now we can solve those two. So let's equate both of them to 0. A minus 1 is equals to 0, so a is equal to 1. And then for the quadratic, that's a squared minus 8a minus 8 is equal to 0. And let's use the quadratic formula to get the roots from our quadratic. So that would be a is equal to minus p plus or minus the square root of 8 squared minus 4ac. And this is all over 2 times 1. So a is equal to, if you punch that into a calculator, you get 4 plus or minus 2 root 6. And let's simplify that. So that's a is equal to 4 plus 2 root 6. If you simplify that, that's 8.9. And then 4 minus 2 root 6. 4 minus 2 root 6 is negative 0.9, and both these values are out of the range of our out of the interval of our PDF. So it means that the only value that's within the interval is the a equals 1, which we got from our linear factor. So we can conclude that therefore a is equal to 1, and that's our final answer. Number 7. A biologist wishes to test whether the mean concentration mu in suitable units of a certain pollutant in a river is below the permitted level of 0.5. She measures the concentration X of the pollutant at 50 randomly chosen locations in the river. The results are summarized below. We've got n is equal to 50, summation of x is equal to 23.0, and the summation of x squared is equal to 13.02. Part A. Carry out a test at the 5% significance level of the null hypothesis mu is equal to 0.5 against the alternative hypothesis mu is less than 0.5. Okay, so we've been given that h naught is mu is equal to 0.5, h1 is mu is less than 0.5. So what we need to do first is to find our test statistic, and we can use this information that we have here to find our test statistic. Our test statistic is x bar, and that's equal to summation of x over n, 23.0 over 50. 23.0 over 50, that remains as 23.0 over 50, so we just leave that as 23.0 over 50. Then let's get an unbiased estimate of our variance. So that's 1 over n minus 1, which becomes 49. Open brackets, the summation of x squared, 13.02, minus the summation of x, 23, and that's squared, and this is over n, which is 50, and we close the bracket. A squared is equal to, let's punch that into our calculator, 1 over 49 times 13.02 minus 23 squared over 50, and that's 61 over 1225. 61 over 1225. This means that our estimate of standard deviation will be the square root of this, and that's root 61 over 35. Root 61 over 35. So this means that x bar follows a normal distribution. We're assuming that h naught is true, assuming h naught is true, so that we can use the mean of 0.5 is true. Our mean here would be 0.5, and then our variance 61 over 1225 divided by n, because this is now simple mean. So this would be 61 over 1225 divided by 50. Let me just simplify that using a calculator. Divided by 50, that's 61 over 61 to 50. 61 over 61 to 50. Okay, and now we need to create our rejection rule. So we are testing at 5% significance level. It's a lower tail test. So this is a lower tail test at the 5% level. So that means our z value is negative 1.645. And we can say that reject h naught if z is less than negative 1.645. So now let's calculate our z value. Z is equal to our test statistic we calculated earlier to be 23 over 50 minus our mean mu, which is 0.5, over our standard deviation, which would be the square root of this value over here. So that's 61 over 61 to 50. So Z is equal to, let's punch that into the calculator, 23 over 50 minus 0.5, and this is over the square root of 61 over 61250, and this gives us negative 1.268. So now let's compare negative 1.268 to negative 1.645. Negative 1.268 is greater than negative 1.645. So this means we accept h naught, and now we have to conclude in context. We are saying that the pollutant in the river, there's not enough evidence. We can conclude that there is not enough evidence at the 5% significance level that the pollutant is below the permitted level. is below the permitted level. And this would be our final answer. Later, a similar test is carried out at the 5% significance level using another sample size of size 50 and the same hypothesis as before. You should assume that the standard deviation is unchanged. Part B. Given that in fact the value of mu is 0.4, find the probability of a type 2 error. Okay, so I'm just gonna sketch our bell curve from before. We had, this is 5% and our z value is negative 1.645. So for us to be able to find the probability of a type 2 error, that's the probability of being in the acceptance region, which is this unshaded region over here. So that's essentially the probability that x bar is greater than c. But we don't know what the value of c is, so we're going to use this value of z to get us to c. So we use the formula for standardizing, that's c minus mu, from before mu was 0.5, and our standard deviation was the square root of 61 over 61,250. 61 over 61,250, and this is equal to this z value over here, negative 1.645. So c minus 0.5 is equal to, if we multiply that by that square root, negative 1.645 times the square root of 61 over 61,250, you get negative 0.05191. So c is equal to, let's add 0.5 to that, c is equal to 0.448, correct to 3 decimal places. And now we can find the probability that x bar is greater than c with our corrected value for mu, and that should give us the probability of a type 2 error. So this is the probability that x bar is greater than 0.448. So if we standardize, that z is greater than 0.448 minus 0.4, which is our corrected mean, and then we are told that the standard deviation is unchanged, so we use the standard deviation from earlier, which is the square root of 61 over 61,250. Let's punch this into the calculator. This is 0.448 minus 0.4 over the square root of 61 over 61,250, and that gives us 1.521 to 3 decimal places. So z is greater than 1.521. So this can be written as 1 minus phi of 1.521. If you read off the value from the normal distribution tables, this is 0.9358. Let's punch this into a calculator to simplify. 1 minus 0.9358, and that gives us 0.0642, and that would be our final answer. So that's all for today's video. If you enjoyed it, please like and subscribe for more videos like this, and comment down below which paper would you like to see me break down next. Bye bye.